We are now ready to tackle basic plotting functionality in Matplotlib. Let's set up the imports first. The imports that we use across our demos will be pretty straightforward. We'll always use the Matplotlib library that offers us low-level control over our plotting. We'll use the pyplot higher level abstraction to build plots. We'll use NumPy to deal with data. I won't repeat this again for any other demo. We'll always be working with Matplotlib in interactive mode. So the plot.show that you see within each execution cell is not really needed if you're in interactive mode. Let's plot the simplest of all graphs and we'll start from there. We pass in the x and y coordinates for our data points in the form of a list of x coordinates and a list of y coordinates. And here is the resulting visualization. Matplotlib has plotted these 4 points on screen and connected them using a line. This is the default representation. By default, Matplotlib draws the line in blue color. Now, if you want to change the color of this line, you can specify the same plot by passing in the color input argument. Here we specified the color in the form of a string. Color is equal to red and the line displayed is red. If you want to give the viewer more information about what this plot represents, you need to specify labels for your x and y axis so that they know what data is being plotted. This you can do by calling the x label and y label functions on your pyplot module. Our labels are super simple here. The X label simply says X. We want it to be displayed with a font size of 15 and we want the label to be green in color. All of these customizations are input arguments to the X label function. Similarly, we specify the same customizations as input argument to the Y label function. The Y label simply says 2 multiplied by X and we give it the font size and the color in which we want it displayed. Notice that by default, Matplotlib adjusts the Y label to align with the axis. You can call the plot function on the pyplot module by passing in just one list of coordinates. If only one list is passed in, it's assumed that those coordinates are Y coordinates. The corresponding X coordinates are simply the index values of these Y elements. In the resulting visualization, you can see that a y value of 4 corresponds to an x value of 0, a y value of 8 corresponds to an x value of 1, 12 is 2, and 16 is 3. Let's generate some random x values here in order to set up some more plots. We do this by calling the np.linspace function. The linspace function in NumPy is used to generate evenly spaced values between a start value, which is 0 here. The upper range is indicated by the stop input argument, which here is 10, and the number of data points that we generate is 50, specified by the num input argument. We'll use these randomly generated x values to plot a sine wave in Matplotlib. The NumPy function np.sinex will generate the sine value for each corresponding x value. So our x label will be the x elements and the y label will be the corresponding sine values, as you can see in the resulting visualizations. Make sure you label your x and y values accordingly so that the user knows what representation they're seeing, what visualization they're looking at. Matplotlib allows you to exercise very fine-grained control over your figure. Here we'll configure the tick parameters for our y-axis. The first input argument says which axis this tick params apply to. The axis is the y-axis and we want the ticks to be red in color. They're really small here, but if you look closely, they'll be red in color. The labels for the ticks are also configurable. You can specify the color in which you want the labels to display and their font size. These are extra large tick labels. We can use the same tick params functions to configure the x-axis. This time we've specified a different set of parameters. We basically said that bottom should be false and label bottom should be false, which means no ticks on the x-axis and no corresponding labels, and that's what you see here. Let's start off with the same sine curve that we've seen before. We have the labels for the corresponding x and y axis. In addition, we want to specify a label for the curve as a whole, which we do by passing in a label parameter to our plot function. If you now specify a legend for your plot, which you can do by calling the legend function on pyplot, the legend will automatically pick up the label that's associated with your curve. Notice that the sine curve here is represented by a blue line, exactly what we'd expect. In addition to a legend, we also want to set up a title for this plot explaining what relationship this represents. This is easily done by calling the title function on pyplot and passing in the text that we want displayed as the title. Let's say you have a really large plot which covers a wide range of values on the x and y axis, but only a portion of this plot is really important and you want to highlight or zoom into that portion. You can do this by specifying the xlim parameters for the limits on your x axis. We've plotted the same sine curve that we saw earlier, but we've limited the x axis to display only those points which are between 1 and 5. We've zoomed into that portion of the x axis. Just like the x limits to limit the range of x values, we can also specify y limits to limit the range of y values as well. Here our y limits are from -1 to 0.5, and only that portion of our plot is displayed on screen. You can use the xlim and ylim functions on pyplot in order to generate mirror images of your plot as well. By switching the xlim parameters, we invert the plot along a vertical axis. Here our x limits are 5, 1, which is different from the earlier 1, 5, and you can see the resulting plot has been flipped along a vertical line drawn through x is equal to 3. This is the center of our range. You can compare this figure and the previous one, and you'll notice by simply changing the x limits, we've created a mirror image of the original figure. We can flip our figure along a horizontal line as well, this time by interchanging the y limits. The y limits are now 0.5 comma -1, which is a reverse of the y limits that we saw previously. You can see the new y limits along the y axis, and you can see that the plot has been inverted along a horizontal line.